arrangements, I'm going to write down here. If you're arranging anything, you're giving it an order. So if you're arranging people in a picture and you put the tallest person in the middle, it's a permutation. You just gave it order. Cards are often combinations because cards, once you get them in your hand, what's the first thing you do? Like if you're playing Uno, you start putting the colors together, right? You can move them. So the order in which they were dealt to you doesn't matter. Unless you were playing like a game like War. Because War, you literally have to give the cards in the order they are. But they never ask any questions like that. Handshakes, the order in which you put your two hands together doesn't make a different handshake, right? So that would be a combination. So permutations order matters, combinations order doesn't matter. And you can remember it as the opposite of a combination lock. Because a combination lock, you have to put the code in a specific order, correct? So it really should be called a permutation lock. But it's called a combination, and I don't know why. To ruin locks. Okay, so the little lock that you work should be called a permutation lock, because the order in which you put those numbers in matters. All right, let's go here. So consider a task made up of several stages. If the number of choices for the first stage is A, and the number of choices for the second stage is B, and the number of choices for the third stage is C, etc., then the number of ways you can do the task is A times B times C times D. It's called the fundamental counting principle. So basically, if there's a few different things that you have to do to get the whole item, you can just multiply all the different options and get the item. So in this case, we have a toy manufacturer makes a wooden toy in 3 parts, and you need to have one of each of the parts. Okay? So the key thing is you need to have one of each. Okay? So option part 1, the top part must be colored red, white, or blue or pink. And I need to take one of these. Choose one. And then I have the middle part must be orange, purple, or black. And I have to choose one. The key thing for the fundamental counting principle is that you need to have a few parts, and then each of those parts you choose one item from each. And then the bottom part may be yellow or green. Choose one. So we're going to show it as a tree diagram just to prove that it actually does work. So part 1 would be along the top, and I'm going to be lazy and not write all the words. So part 1 is here, and my options are red. Please leave spaces because you're going to have arrows off of them. So we're going to have red, then we're going to have white with a space, then blue and pink. And I'm leaving spaces because I'm going to put little arrows off. So that's part 1. Then part 2, and the tree diagram just lists all the different outcomes that you could possibly have. Part 2 is orange, purple, or black. So part 2, if part 1 was red, then this could be orange, purple, or black. If this was white, then this could be orange, purple, or black. This could be orange, purple, or black. And then this could be orange, purple, or black. So if this toy only had 2 parts, I could make 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 distinctly different toys, right? 12 toys that looked completely different. Do you see what I did there? I could have 12 if it was only 2 parts. But there's not 2 parts, there's actually 3. There's yellow or green as well. So if the top was red, this was orange, the bottom could be yellow or green. So that would get me 2 more toys from the 2 that I had. Then this would be yellow or green. This could be red, then, I don't remember what the colors, blue or black. Black, then yellow or green, yellow or green, yellow or green. So how many distinctly different toys could we have? Well, this Roy would be 1, then Rog would be 2, then Rupee would be 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 different toys. And it makes sense because until we added the extra 2 options, we actually had 12. And what would we do with that 12? We times it by 2 options per each of those options, right? So that's what we got, 24. Now we can spot this as a fundamental counting principle as there's a few parts that you need to use to make the whole object, and you're picking one of each of those options, right? I'm choosing one from part 1, one from part 2, one from part 3. If I choose more than one from each part, it's not the fundamental counting principle anymore, okay? So if I want to use fundamental counting principle, I can just do 3 blanks. This would be part 1 options, this would be part 2 options, and this would be part 3 options. How many options, different options do I have for part 1? How many different options? 4. Part 2? 3. And part 3? I have 2, yellow and green. We agree? Now, do I need part 1 and part 2 and part 3 to make the toy? Or could I have part 1 or part 2 or part 3 to make the toy? And or? Do I need part 1 and part 2 and part 3? Or could I use or? It's and, right? If you're using the word and, I'm going to put this in big letters to help us out. If I use the word and, I will multiply. And if I use the word or, I will add. How do I remember this? Because and add look very similar, don't they? They're just a D and an N difference. They look so similar, they are not together. So and does not go with add. They're too close together. And I multiply or I add. Because if I can take this, or I can take this, or I can take this, I'll take this many options plus this many options plus this many options. Or it makes sense to add. Because I would take this many options and then I would add these ones and add these ones. And means I need these ones and these ones and these ones, so I'm going to multiply. So if I go, I need part 1 and part 2 and part 3, like if I can use the word and in between all of these, I'm going to multiply and I just use little dots. Multiplication, which equals 24 different toys. So the fundamental counting principle is way faster than the tree diagram, right? Okay, then we're going to flip over. So here we have a school cafeteria offers sandwiches made with fillings of ham, salami, cheese, or egg. So that's my one option. On white, whole wheat, or rye bread. Then I have to keep reading because I can only pick one of each item. If I pick more than one of each item, I can't use the fundamental counting principle. Remember? So let's keep reading. How many different sandwiches can be made using only one filling? So I need one filling. If I can say I'm using one of it, this blank represents choosing one of it. One filling, and, so I have the word and, one type of bread. One means I can use the blank, bread. And means I do what? Multiply. So now I can fill in the stuff. Fillings, how many filling options do I have? Ham, salami, cheese, or egg? I have 4. How many different types of bread? 3. White, whole wheat, or rye? How many different sandwiches? 12 different sandwiches. Remember, if it's a word problem on your diploma in the written response, you have a sentence. So in this case, I would say, there are 12 different sandwiches that can be made using with only one filling and one type of bread. Basically reiterate the question, right? Okay. This one here, we have a Math 30 quiz, consists of 8 multiple choice questions. So I have question number 1, question number 2, question number 3, question number 4, question number 5, number 6, number 7, number 8. All right? Now we have to ask ourselves, and or. Do I have to do number 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8 to complete the test? Or could I just do number 1 or number 2 or number 3 or number 4 or number 5? When you do a test, you need to and them, right? Unless your teacher's like, do 1, maybe all of them, whatever you feel the need. Wouldn't that be sweet? You just walk away and do none. All right. So there's an and in all of these, so I need to multiply. Now remember, I can only use this fundamental counting principle if I keep reading and I'm allowed to pick one option for each blank, right? That's what the blank means, one option, one option, one option. So here it says each question has 4 choices, A, B, C, or D. Those are my options that I have for the blank. How many answers, different sets of answers are possible? Well, we know for a multiple choice, how many answers can I pick per question?
4.
That's right. How many answers can I pick? I'm making an answer set here, like an answer sheet. How many questions can I pick for, like, how many would be correct? 1, right? So I'm choosing one answer per blank, correct? One correct answer per blank. That's why I can use these blanks. Because I have one correct answer here, one correct answer here, one correct answer here, one here, one here, one here, one here, one here. That's why I can use the blanks, because there's one correct answer. Above the blank is where I list how many options I actually have. So how many options do I have? 4. So the blank represents I can only pick one, right? One correct, like your teacher's like, choose the correct answer. So you have to pick one. You're not allowed to pick 3 out of 4. Your teacher just marks you right if you happen to grab the right one. Okay? So I have 4 options for this one, and 4, and 4, and 4, and 4, and 4, and 4, and 4. And then sadly people tell me that's 4 times 8.
No.
It's 4 to the, I heard someone whisper it.
4
to the power of 8, which is a large number. What is it? So people who think they know nothing about an 8-question test and can guess right, you have a 1 in 65,536 chance of getting 100 on an 8-question quiz by just sheer guessing. Because there are 65,536 different answer keys to an 8-question quiz. 65,500, because you could have all A's, right? And then you could have 1A and then all B's, and then 1A and then all C's, and 1A and all D's, and then you could have all B's, and then B, and then 1 and A, and then a B, and then, you know, so there's lots of different options you could have. Yeah? It was longer than that, so you had a distinctly crappier chance of. I think it was 12 multiple choice and 6 numeric. Okay, the numeric throws you right out the window because that's a lot of guessing. Okay, so the way they could ask this question, paying attention, is they could say Mrs. Lepp was answering, yeah. They could say that Mrs. Lepp was marking a Math 30-1 final, okay? And a gust of wind came through the window and knocked over her coffee. And her coffee spilt on the first 10 out of 12 questions. How many different answer keys could she have? So the coffee spilled on the first 10 out of 12 questions. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We need ands because we're still writing all the test questions. How would it change it? Mrs. Lepp's coffee spilt on the first 10 out of 12 on the answer key. So how many options do I have for this one now? 4 still, because this is washed, right? Like the coffee spilt on it, it's gone. Question number 1's gone. What about number 2? How many options would I have? 4. I'm making how many different answer keys I could have? What is the cup? 4. This is the 4th question. The 5th question. The 6th. The 7th. The 8th. The 9th. The 10th. The 11th and 12th. Did they get washed away?
No.
How many options do I have for this one? 1. And this one? 1. Totally changes it. Because they didn't get wiped off. The coffee spilt on the first 10 answers. So can I see 11 and 12? The coffee spilt on the first 10. Did it spill on 11 and 12? No, I see 11 still B and I can see 12 is still D. So how many options do I have for 11? 1. How many for 12? 1. So Imogen, because the coffee spilt on the answer key. So the first 10 I don't know the answers to. 11 and 12 I do know the answers to. So how many options do I have for 11? 1, whatever the heck the answer is. And how many for 12? 1. So technically I'm kind of looking at an answer key of 10 questions. Options of how many different 10 question answer keys I could have because I know 11 and 12 already. So if it's spilt on the first 6, then the first 6 would be 4, 4, 4, 4, 4, 4, and the last 6 would be 1, 1, 1, 1, 1, because I could see the answers. Does that make sense?
Yeah.
Okay. Nice stash, Grady. I can see it from here. It's a beauty. All right. Grady Hale graduated a couple years ago. Okay. Fundamental accounting principles involving restrictions. Okay. So we have when solving problems involving restrictions, it's important that you deal with restrictions first. Underline that, highlight that, memorize that, put it into your being. Restrictions must be dealt with first. So actually the way I did this question was wrong. I should have dealt with these two first. Why? Because they actually had answers, correct? This was C and this was D. I should have put a 1 and a 1 and then reverted back to 4, 4, 4, 4, 4. Right? Okay. So here we have example 4. In how many ways can 5 different models, now this matters. You have to look for this, 5 different models. 5 different models of black cars means I could have like a Ford Focus beside a Ford Mustang, and they're the exact same black. Can I tell them apart? Yes. They look very different, correct? Now, think about it this way. Everyone's paying attention because when you partially don't pay attention, you'll be lost in this unit. It is very different, okay? So say I take 5 Ford Focuses. They're all the same year. They're all the exact same black car. Okay? I line up 5 Ford Focuses in a line. I tell you to close your eyes, cover your ears. You can't hear, you can't listen, you can't see anything. I move all 5 cars and I put them all back in the same spots, but they're actually 5 different cars in different spots. You open your eyes, you unplug your ears, and you tell me you've done nothing. It looks the exact same left. You literally left the cars there, right? Because you wouldn't be able to tell that I moved 5 cars around because they look the exact same. It's like having B, 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 B as my 5 Ford Focuses that are black, right? And I move them around. Wow. Did they move? Did they move? No, you can't tell. Shh, I'm a magician. Boom, they moved again. Can you tell? You can't tell when they're the exact same, correct? But, paying attention, different black cars. B1, B2, B3, B4, B5. This represents, you can tell the difference between the cars right now, right? Because B1 is a different looking car than B2, than B3. Okay, I swapped them. Can you tell the difference now? I have 2 3s, that's real problem. Can you tell the difference now? Yes, because you can literally tell the difference in the cars because they have different little numbers with them. So when it is 5 different models, there's no repetition. They're all different looking. I don't care that they're all black, that's great. I can start with a black car and end with a black car, that's important, but I can tell the difference between them. Do we understand that? So we have to look when it says 5 of the same black car or 5 different black cars makes a difference. 5 of the same black car means we have repetition of black cars. I have 5 of the exact same. If I do this or I move them all around, you can't tell the difference. Okay? But today you can because they're different. So I have, in how many ways can 5 different models of black cars and 4 different models of red cars, which I'm going to put in red. And you should highlight and underline as you're going on. Can be parked next to each other in a parking garage. So they're next to each other. Car, 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 car. Right? You think that's funny. Mrs. Lepp thought they stacked in high school. I sucked at this unit. I'd be like, 5 and 4. They're all used up. Like, did I think I stacked the cars on top? I don't even know. I pray for myself. It's fun. Okay. If a black car has to be first, does it say what kind of black car? It just has to be black, correct? And a red car has to be last. Okay. Woo, didn't mean to do that. How many cars are we parking? 9. Yes, we are parking 9 cars. Now, every single blank represents putting how many in that blank? 1, correct? I really wish that would have been said to me. I'm pretty sure it was, but I was just not paying attention. I guarantee you, I stacked them. I was like, 5 and 4, we're good. And I'd be like, but now there's spaces and all the cars are parked. Like, how did I not think, like, are you stacking the cars? Like, it's scary. Okay. So I have one car parked here. One car here, 2, 3, 4, 5, 6, 7, 8, 9. We agree? And each of those blanks, I'm like, one car, and then park another car, and then park another car, correct? Now, we have to decide if we're multiplying or adding. If we're using the fundamental counting principle, we're always multiplying. But let's just decide, are we parking this car and 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 this car? Or are we parking this car, or we can park this car, or we could park this car, or we could park this car. What are we doing? And because we're trying to park all the cars, this car and this car and this car and this car, I need to park all 9 cars. So it's and. So if it's and, I'm going to multiply. Now there's a whole bunch of people who, when it comes to the test, don't put the multiplication symbols and then just give me a multiplied answer, and they're like, you can figure it out. No, that's not how it works. You need to show the multiplication symbols so that you can show the person marking it that you're multiplying. They shouldn't have to figure out that you're multiplying because they put the numbers together by adding or multiplying and they get the same thing as you. That is not how it works. You need to show the operation. Yeah?
I might be being really stupid here, but can we technically also say or? Because you're saying like you have a red car there or a black car there, and I might be like.
No, or means you could park one car or you could park all 9.
Oh, okay, never mind then.
Right? So we're doing like that I can have black or red just means more options.
Okay.
But what we're saying is I have to park the first car and the second and the third and the fourth to park all 9.
That makes more sense.
Yeah.
I think I'm just getting the wording messed up in my head.
So, paying attention. We now have to write, I always write below what distinct options have to happen. Okay? So it says here that a black car has to be parked first. So we put a black car first. And then a red car last. Black car first, red car last. We agree?
Yes.
Now those are restrictions, aren't they? So they need to be dealt with first. Ready? This is going to be, honestly, I understand this is hard because I stunk at these. So it's always my goal for people not to be as bad as I was. Okay? And I believe that no one ends up as bad as I was, so I feel like it's a good thing. I've accomplished things. So, I felt like I was like blessing you with some more. Okay, anyways. Black. How many am I sitting in that space? How many options do I have? 5. But how many cars am I parking? 1. We agree? 1 blank, 1 car. Yes? How many? So here I'm parking. Put my finger on the dot thingy and then across. Good, we're all good. Okay, I'm parking 1 car here. We agree? Above the blank, if I can get you to understand this, you will rock at this unit. If I cannot get you to understand this one concept at this very moment, it will be scary for you. So we're paying close attention. Above the blank, we list the number of options, not how many cars were parking there. Lepp did not understand that when she was Wagner and she was in high school. She did not understand that. She thought she was parking 5 cars. She's not parking 5 cars. She, the blank, shows that I am parking 1 car, but above I list how many options of cars I have to park there, but I'm still only parking 1 car. We agree? If I can get you to understand that, this unit, golden. So, parking 1 car because it's a blank, how many options of cars do I have? 5. Okay, now I go to the red.
4.
Red cars, I have 1 blank here, so I am parking 1 car. We agree? Now, how many am I actually allowed to park? 4. Now, we have to decide, have we parked all 9 cars? No. Wagner back in the day would have been like, all 9 cars are parked. What if I got to put in the other blanks? I'm done. Like, what? I think I was like stacking them, like, seriously. So, because I didn't understand that the numbers above was the options, not how many I was actually parking. Correct? So in blank 1, I parked 1 car. In blank, the end blank, I parked 1 car. So I've completely parked how many cars? 2 cars out of how many cars? 9. Is there any distinct like restrictions on those middle blanks? Does it matter if they're black or red? No. So I can go back to the left. I can start on the right. I always like going left to right. It's just a thing. I follow the same order and I find it easier. So I'm going to go over here. I parked one car, I parked one car, I parked 2 cars. I have how many left to park? 7. So I have 7 options for this blank. We agree? Then I park a car. So how many do I have left for here? 6. Then I park a car. How many do I have left for here? 5. Then I park a car. 4. Then I park a car. 3. I park a car. 2. I park a car. And then last car goes there. Does that make sense? I left grade 12 and never understood that. It was sad to say. So I'm hoping you do. Now, we're multiplying all these numbers together. Everyone paying attention because you're going to learn something here. You're going to learn a button on your calculator. So we have 5 and 4. 5 times 4 is how much? 20. So I can do this. I could go like this. I could go 5 times 7 times 6 times 5 times 4 times 3 times 2 times 1 times 4. Enter. Boom. Get an answer. I could absolutely do that. We agree? Or I can go 5 times 4, which is 20. And then I multiply by 7 factorial. What the heck? It's not 7 screaming. It's not like 7! That's not what it's doing. It's 7 factorial. 7 factorial. You can use the factorial symbol, listening to me. You can use the factorial symbol if and only if you started a number and you go down by 1 all the way to 1. So like I went 7 times 6 times 5 times 4 times 3 times 2 times 1. The factorial symbol will put that all in for you. Now, if you went to the number 2, could you actually use the factorial symbol? Technically, yes, because when multiplying by 1, what does it do? Nothing, right? So if I went 7 times 6 times 5 times 4 times 3 times 2, or 7 times 6 times 5 times 4 times 3 times 2 times 1, I would actually get the same answer, because multiplying by 1 does nothing. So if you went till 2, you can, but you have to go down by 1 each time. So you're going to go 20 times, everyone's trying this out on their calculators, 20 times, and now you're going to go 7. And to find the factorial symbol, you go math, arrow to the left one. It'll pop into the probability faster. And then press number 4. Boom, does it for you. So you can go 20 times 7, math, arrow left 1, it pops your probability. You could arrow right 3 times too, it doesn't matter. You get to the probability PRB, and then you pick number 4, which is the exclamation point, correct? And then enter, it puts it in for you.
There's 4 sections, so 0, whatever, 20.
You have to on the new ones. The old ones do not have that. So, how many ways can we park these cars? 100,800 ways to park 9 different cars with a black car in the front and a red car at the back. Okay, we're looking here. Eric has been assigned the task of how many odd 4-digit numbers there are. He has been told that the number such as 5267 is a 4-digit number, whereas 0267 is classified as a 3. They'll never tell you that on the diploma, okay? So they're going to say how many odd 4-digit numbers are there. 4-digit numbers have how many blanks? 4, correct? Because one number can go in each blank, making a 4-digit number, correct? So I know at the very least I have 1, 2, 3, 4. Now in here, did it say I can repeat or not repeat numbers? Like, can I have 3, 3, 3, 3? Sure. It doesn't say I can't repeat numbers, okay? It does say that it has to be odd. How do you know if something's odd? Listen for a second. People will tell me you can't divide by 2. That's lovely. Not helpful for this. So, how can you tell something's odd? You tell me. 65. Odd. 63. 64. 67. What am I only changing? The last digit. Now, let's think about this. Paying attention. 1,475,563,902. Even. You don't listen to anything else except for the last digit, do you? So in order for something to be odd, I only care about my last digit having to be odd. Do you agree? So that's a restriction, so I'm going to deal with it first. Now, in this, how many numbers can I fit in this blank if I'm using a blank? Whenever I use that blank, how many cars did I fit there? 1. How many letters did I fit there? 1. How many numbers can I fit there? 1. So a 1-digit number can fit in there. 2-digit number, can it fit in there like 12? No, that's a 1 and a 1. That's 2-digit numbers. I can't fit that in there, correct? So all I can fit when I do a blank is 1-digit numbers. So I can have 1. Remember, I list the options below, state how many are above. So I can have a 1 here, or a 3, or a 5, or a 7, or a 9. I'm listing all the options below. We agree? Can I have 0 there if it's an odd number? 4? 8? No. So that's the only numbers I can have. This is the next thing you have to remember. If they say 4-digit odd numbers, ready? I'm going to pay you in a 4-digit odd number. Ready? 0, 0, 0, 1. There you go. You're welcome. I paid you in a 4-digit. Is that a 4-digit odd number?
Yeah.
Is that a 4-digit odd number? No. That's just a whole bunch of zeros sitting in front, and you're like, Lepp, you ripped me off. You just paid me in 1-digit number. It's a 1. Okay? Okay, never mind. I'm going to change it. I'm going to pay you in a 4-digit odd number. 0, 2, 6, 7. Now how many did I pay you in? 3-digit number, didn't I? With a fake 0 sitting in front. Okay? So if I say 4-digit code, listen, 4-digit code. A code. Could a code start with a 0?
Yes.
Yes, a code could be 0000. Everyone's breaking into your house, but it for sure could be 0000. That's a code, correct? But a digit number, can it start with a 0? No. A code can start with a 0. A 4-digit number can't start with a 0 because that's just a 3-digit number disguised as a 4-digit number. Okay? So if it says 4-digit number, you should leave yourself a little side note, a little arrow, a little star. If it's a 4-digit number, the other thing it's indirectly telling me is this can't be a 0. That's the only restrictions on this thing, right? Is there any restrictions on the middle 2 numbers? No, it just needs to be a 4-digit odd number. So the first digit can't be a 0, the back digit has to be odd. Okay, we have to deal with the restrictions first. We agree? So 1, 3, 5, 7, 9. How many options is that? 5. I'm putting 5 options here, but am I putting 5 numbers there? No, I'm putting 5. I have 5 options, but I'm still only leaving 1 number. The 1, the 3, the 5, the 7, or the 9. We agree? Okay. This one, it can't be a 0, but it can be the numbers 1 to 9. How many digits is that? And if you tell me the wrong number because you don't count it on your fingers because you're ashamed, that's shameful. At least count it out. 1, 2, 3, 4, 5, 6, 7, 8, 9. Some people will tell me 10. Some people will tell me 8. It's a scary place to be. There are 9. From 1 to 9. 1 to 9 is a little easier to tell. 0 to 9, people will tell me it's 9, but it's 10. So if you have to hide your fingers to make yourself feel better, I don't really care. As long as you get the right number from 1 to 9 in that blank. Okay? So 1 to 9 has 9 options. We're going to put a 9 here. So that doesn't mean I left 9 numbers there. It doesn't mean that the number 9 is there. It means there's 9 options for that blank and I've left 1 number. We agree? That's what that means. Now the middle blanks, what letters? None. That's what the answer is. What numbers could I put in those middle blanks? 0 to 9. And 0 to 9 is how many options? 10. Wagner back in the day thought this was the number 910,105. And I had no idea what the heck we were doing because that's what I thought it meant. Because I was stupid. That was me before I got married. Just a dummy. Just a dummy. I had really good in all math except for this unit. I was dumb. Like, not even slightly dumb. I was stupid. I just looked like prayed that I circled the right answer. It was a problem. I prayed for more multiple choice than me. That's what I did. Okay. So, I need you to do better than me, and I need you to understand why. So, I have 1 option, 1 option, 1 option, 1 option. I had 9 options for this blank, 10, 10, and 5, but I picked 1 number here, 1 number here, 1 number here, 1 number here. So, it's still only 4 numbers. Why am I multiplying them? Because I need the first digit and the second and the third and the fourth to make a 4-digit number, correct? I can't have just the 1 or the 2 or the 3 or the 4. I can have a 1-digit or a 2-digit or 3. I won't have a 4. So I need to multiply. So I actually have 4,500 different 4-digit odd numbers. Okay? Well, it's just 9 times 5 with 2 zeros. You're welcome. Okay. Every time you multiply by a 10, you just get another 0, right? All right. B is very similar to C, except it has a little twist. Eric has been assigned the task of determining how many odd 4-digit numbers there are. Sounds very similar to the previous question. But which have no repeating digits. Okay, remember how I told you if you pay attention, this will be a really easy unit, and if you don't, you'll be lost? Here's another time. You need to pay attention. Okay? If you do this every single time there are no repeating digits, you will get every question right. If you choose not to go this route, I will pray for you and hope you get it right. That's what I will do for you. Okay? So, 1, 2, 3, 4. I still have 1, I still have 3, I still have 5, I still have 7, I still have 9, but I have options for that last blank. We agree? Has that blank changed? The options? No. How many do I list above? 5. I still have to deal with my restricted blanks first. We agree? Okay. So I had 5 options for this one. We agree to this point. We agree? Yes? Yes? Now, I'm going to pretend to keep a number there. Because if I pretend to keep a number there, I won't use it in the next one. And I can't use it in the next one because I'm not allowed to repeat. Correct? So this is the key thing, that if you do this, you will rock this. Okay, I have 1, 3, 5, 7, or 9. Which one do I want to keep? It doesn't matter. The middle one. I usually pick 1 or 9 because I'm lazy, and then I can go like 2 to 9 with an arrow in the next one. But he's a rebel, so we're going to pick 5. So I'm going to pretend to keep 5, so I'm going to box it. If you remember this step of boxing a number, you will get this right every single time. So I'm boxing the 5, I'm pretending to keep it. If you box the 1, you pretend to keep that, 3, 7, it doesn't matter. Pick 1, box it, it's done. You can no longer use it as an option that is gone. Okay? So I go to the first blank. I know the first blank can't be 0. Why can't it be 0? Because then it's not a 4-digit number, it'd be a 3-digit number. We agree. What else can it not be now? 5, because we boxed it. 5 is out. No thank you, 5 is gone. So instead of having 9 options, I now actually have 8. I'm going to list them. So I have 1 to 4, 6 to 9, which is actually 8. Now which one do I want to keep? Sure. We'll keep 6. How do we know we keep 6? We box it. So people will tell me 1 to 4, 7 to 9. And this is where the error happens every single time. So if you would go 7 here, then 6, that answer will be there. It's going to be wrong every single time. Because the 0 can be in that blank. The 0 couldn't be in the back blank because of why? What reason? It had to be odd, correct? I couldn't use the 0. I couldn't use the 0 in the first blank because it had to be a 4-digit number. So people will just forget that the 0 can come back in the second one. So I have to put a 0 back. So it's actually still 8. Now I have to hold 1. I'm going to hold the 0 because it's just sitting down here. So now I have 1 to 4, 7 to 9. If you're someone and you know who you are, that's like, yeah, I'm never remembering that 0. You box it, you highlight it, you put a star in the notes beside the number. You highlight the star. You write, don't forget to bring the 0 back in the second blank. You star, star, star. Highlight, highlight, highlight. You know who you are. It's 70% of you, at least, will forget that 0. And if you're like, that's not going to happen. Yes, you will. I've taught this course a bajillion times. You will forget. Even if at this moment you didn't forget, you'll probably forget the test. Because remember, when you get to a test, your guys' brains fall out of your head a little bit because your anxiety levels get a little higher, right? So we need to have everything like backwards and forwards remembered in our heads, put right into our heads right before we go there so that when our anxiety levels rise, the information doesn't fall out. I'm not making fun of you, I'm being honest. That's what just happens. When your anxiety level comes, you're like, stuff you know just like literally flutters away into the abyss. Okay? So we have to have that stop happening. How do we stop having that happen? We highlight, we star, we remember it. We go before the test 4 days before, and we go, don't forget the 0. Do the question again, cover up the answer, forget the 0 again. You're like, oh, forgot the 0. Don't forget the 0. Use the question again. Remember, you can go through your notes and cover answers, can you not? Try the question out without looking at the answer, see if you get it right. If by the 4th time you've done it, you have not made a mistake, for 4 times. It has to be 4 times you go to do that question, you cover it up, and you don't make any mistakes anymore. It's now long-term, not short-term, and it won't fall out for anxiety. Okay? If you have to cheat sheet it and be like, oh, the 0, the test is going to go bad because you're going to forget it. Right? So you have to be able to do that question 4 times without having to look and see that you have to remember that 0 for its long-term. You get what I'm saying? So if at any point in time you're going to do a question and you have to look at the sheet to get the answer to remember what step you have to do, not going to go well on the test. If at any point in time you have to look and be like, oh right, I need to replace this here. That's scary for me if you're doing that, because I know it's not there. Okay? All right. I hold the 0, then I have 7. 8 times 8 times 7 times 5. 64 times 35. 2240. I'll do one more here. So here we have car number plates in an African country consists. I hate this one. I'm going to pretend we're doing Alberta. It's not worded well. It's worded really. Okay, we're in Alberta. How does an Alberta license? Oh, darn it! Don't move. You're gonna. If you keep scrolling, you're gonna see this. Questions to try. 1. Oops. 2, 3, 4, and 5. Now, if you're wondering where the answers are, if you just keep scrolling, go to the next page, scroll, boom, here are the answers.